Welcome to solverfy.
In this question, the conical bearing is subjected to an axial load. This is an axial load, and the coefficient of static friction is given as μs. Let's determine the torque that must be overcome the friction. So this is a conical shaft. So let's suppose this is the cut section. Consider. So this is the normal, and this length is ds. Okay. So if you consider this angle, so this angle is theta degree, and this radius is small r, and this is capital R. So the axial load that is applied on this conical shaft. So let's determine the torque that must be overcome to the friction. So the elemental area is equal to, area is length into breadth. So the breadth is ds and the length is 2 pi r. So, and we determine the angle cos theta. Cos theta we can write based upon hypotenuse. So we get the value of ds is equal to dr by cos theta. So the elemental area is 2 pi r dr by cos theta. Now the intensity of pressure. Intensity of pressure is load upon area, and the area of this base is, the radius is r. So we can write pi r square. So this is the intensity of pressure. Now we determine the normal reaction. So normal reaction is equal to intensity of pressure into elemental area. The normal reaction on this is the normal reaction. So this is the normal reaction. This is P pi capital R square, and the elemental area is 2 pi r into dr by cos theta. So this is 2 pi, this is 2p divided by r square cos theta, and this is r dr. Now we determine the torque. So the expression of torque is equal to perpendicular distance into force. We can write force is equal to coefficient of static friction into normal reaction. So this is dm is equal to mu s into 2p divided by r square cos theta. This is r square dr. For complete torque, we can integrate this equation into 0 to r. So the value will be get 2p, this is mu s, this is r square cos theta, and this is the value of r cube divided by 3. This is cancel out. The torque that must be overcome the friction is 2p coefficient of static friction. This is load, this is 3, this is cos theta, and this is the radius of the conical shaft. So this is the answer. This is the torque that must be overcome the friction of conical shaft is 2p mu s r divided by 3 cos theta. So this is the final.